Hi students. In the last lecture, I have discussed loss of reflection and the problems based on that. Let us now continue. See the first problem. A reflecting surface is represented by the equation y equal to 2l by pi sine of pi x by l. X lies in between 0 and l. A ray traveling horizontally becomes vertical after reflection. The coordinates of the points where this ray is incident. This is now shape of the reflecting surface, and this is now its equation, right? And we have to see where the ray is incident. We can see one possibility: light ray travels left side, then becomes vertical. Second possibility, it travels towards right side and becomes vertical, right? Let us see how we start the problem. Let us make a diagram. This is now reflecting surface. Let us take light ray is traveling towards left side, then becoming vertical. Given this is y and this is x, you can see here normal at this point, at the point of incidence. Angle of incidence equal to angle of reflection. And see, total angle is now 90. Since both are equal, those values must be 45, right? Angle of incidence, angle of reflection, both are equal. Total is 90. And if you draw tangent at this point, if you draw tangent at this point, that tangent makes angle 135. See carefully. It is 135 with a positive x-axis. That means slope equal to -1. And next possibility is light ray traveling towards right side becomes vertical. If you draw normal at the point of incidence and see tangent here, the tangent makes an angle 45 with a positive x-axis, right? That means at this point tangent means slope equal to +1. That means dy by dx is equal to ±1, right? So here slope is -1 and here slope is +1. And see how to get the slope. The given equation y equal to 2l by pi sine pi x by l. Now differentiate this. Differentiate y with respect to x to get slope. So dy by dx that is equal to 2l by pi derivative of sine that is a cos pi x by l. Now derivative of inner function that is pi by l, right? Now see the simplification part. Pi and pi gets cancelled. L and L gets cancelled. Remaining is now here slope is ±1. So it is 2 cos pi x by l. That means cos value plus or minus 1 by 2. Plus or minus 1 by 2 means this value must be equal to either 60 or 120, right? That means pi x by l should be either 60 or it is equal to 120. Okay. Now see pi gets cancelled. X equal to L by 3 or it is 2L by 3. Okay. And if you want y coordinate, you can see y equal to taking sine 60 or sine 120. Both are same, right? It is a 2L by pi sine 60 or sine 120. It is root 3 by 2. So 2 gets cancelled. It is now root 3L upon pi. Okay. So having two x values, L by 3, 2L by 3, and corresponding y value, root 3L upon pi, right? So answer is option B and option D, right? Let us see next problem. Figure shows a torch producing a straight light beam falling on a plane mirror at an angle 60. The reflected beam makes a spot P on the screen along y-axis. If at t equal to 0, the mirror starts rotating about the hinge with an angular velocity 1 degree per second clockwise. Find the speed of the spot on the screen at t equal to 15 seconds. See diagram for this one. This is now torch, which is now producing straight light beam reflecting from the mirror and falls on the screen, right? So we have to find velocity of this point when t equal to 15 seconds. And see carefully definition of velocity. It is the rate of change of position vector, right? See how to start the problem. Let us make a diagram. This is now mirror. Normal at the point of incidence. Angle given 60. Reflects now. And this is a point. And for this point, we have to find velocity when t equal to 15 seconds. This is point P. Now see carefully. A mirror rotates clockwise, given omega value 1 degree per second, right? And we have learned that when mirror rotates by an angle theta, a reflected ray rotates by an angle 2 theta, right? So initially this ray making angle 60, right? Let us take at one instant. Do one thing, take separately. This is initial normal. I'm taking it as N1, initial normal. Now, take this is a present normal. This is N2. This normal makes an angle theta with initial norm. Okay. So this is now mirror. And see coming to the instant ray makes an angle 60 minus theta with the new normal. This is now instant ray. It makes angle 60 with N1. With N2, it makes angle 60 minus theta, right? When this mirror rotates by angle theta, this reflecting ray rotates by an angle 2 theta. That means now this angle becomes, that angle becomes now 60 minus 2 theta. See carefully. This point we have discussed in the last lecture, right? Mirror rotates by angle theta. Getting the point. Then reflecting ray rotates by an angle 2 theta. When this rotates by angle 2 theta, then this makes angle 60 minus 2 theta with vertical. That means now this angle, that is 60 minus 2 theta. If this point is clear, remaining is just a calculation part. Let us take here, let us take distance of point P from origin, take it as y. Okay. Let us take this as x-axis. For this point P, there is no change in x coordinate. Only y coordinate is changed. That means velocity of that point is nothing but rate of change of its y coordinate. Okay. Now see how to get this y coordinate. I can take this is given as 3 meter, this distance. This is y. So tan of 60 minus 2 theta, that is equal to 3 by y. Opposite side by adjacent side. From that y equal to it is a 3 cot 60 minus 2 theta, right? Now differentiate that. dy by dt is equal to that is equal to 3 into derivative of cot minus cosecant square 60 minus 2 theta, and see derivative of inner function for 60 0, remaining is now minus 2 into d theta by dt, right? So minus gets cancelled. Remaining is now 3 and 2, 6. 6. We have to calculate velocity when t equal to 15 second. In 15 second, theta value. Theta becomes now 15 degree. Then this 2 theta, that is now 30. 60 minus 30, that is 30. Cosecant square 30, that is a 4, right? Into d theta by dt, that is given as 1 degree per second. And converting that into radians, it is a pi by 180, right? 1 degree equal to pi by 180 radian. Then see what we get here. 6 here, 30 times, and 4 here, 2 times, here 15 times. It is now 2 pi upon 15 meter per second. That is velocity of the spot when t equal to 15 second, right? Let us see next problem. Okay. Now let us discuss what is object and what is image. Okay. Let us see carefully. So coming to object, object means light rays coming from that body. Okay. For example, this is a mirror. This is now mirror. So taking a plain mirror. light rays are coming from the object. So like this in all directions. So we are focusing light rays only which are falling on mirror. You can see here light rays are diverging from the object. So whenever light rays are diverging from the object, that is known as real object. So how to know object is real means rays are diverging from that body. Then that is called real object. So here rays are diverging from the body. So this is now real object. Okay. For example, for example, we are getting here a converging beam. This is now light ray like this. This is a converging beam. A converging beam is falling on the mirror. Now see what happens if there is no mirror. If there is no mirror, if we extend these rays, they will converge. They will converge. They will converge now at this point. And this is known as virtual object. That means if a converging beam is falling on the mirror, or if you have a lens on the lens, then it is virtual object. So if you are not having that mirror, where these rays are going to converge, that will be the location of virtual object. Okay. Now we got here real object means rays are really diverging. A virtual object, a converging beam falling on the mirror, and the point of convergence is called virtual object. Okay. Next, now coming to image, see first diagram. After reflection, the rays will, we can see here rays are now diverging, right? Rays are now diverging. If you extend these rays back, if you extend these rays back, the diagram is not correct. Let me correct once. Right. If we are extending these rays back, extend these rays back, where these rays are converging, that is known as virtual image. And you can see here, rays are now really converging after reflection. Rays are really converging after reflection. So this is now real image. That means after reflection, if rays are really converging, then that is real image. If rays are diverging after reflection, if you extend those rays back where they meet, that is virtual object. So real object means, sorry, virtual image, okay? Real object means rays are really diverging. Virtual object, we are having a converging beam and point of convergence is called virtual object. Next image, after reflection, if rays are really converging, then image is real. After reflection, if rays are diverging, then image is virtual. And the point of point of divergence, that is known as virtual image, that location. Okay. And let us see one more point here. Here we have taken a plane mirror. Whenever a diverging beam falls on the mirror, it always diverges. I am repeating. Whenever a diverging beam falling on the mirror, it always diverges. That means a plane mirror forms virtual image for real object. A plane mirror forms virtual image for real object. And coming to here, for virtual object means if we have converging beam, then after reflection, rays will really converge. That means a plane mirror forms a real image for virtual object. Okay. And we can see one more conclusion here. Let us see that conclusion. Suppose here angle of incidence, take it as the CSI, angle of reflection. Again, same. If this is I, this is also I, right? And you can see I am taking same line and this is same line. This is also I. Okay. This is O and this is image I. Let us take this point is A. See carefully the triangle. This is taken as B. Now see triangle OAB. Next ABI. These two are now similar triangles because here angle is I and this angle also same. This is now common for both. That means from this diagram we can say OA is equal to AI. See carefully. I am saying that OAB, ABI. These two triangles are similar because angles are same. That means we can say that OA and AI are equal. OA is nothing but distance of object from the mirror and AI distance of image from the mirror. That means distance of object from the mirror is equal to distance of image from the mirror. So this is one important point which we are going to use to find out velocity of image. Okay. Let us see once problems based on this. First focus the points till now what we have discussed. An object is real if light rays are really diverging. An object is virtual if a converging beam falls on a mirror or lens. An image is real if light rays converge after reflection or refraction. Okay. An image is virtual if light rays diverge after reflection or refraction. Okay. And one important point here, we can get a real image on screen, but not virtual. Means we can catch a real image on a screen, but we cannot get a virtual image on screen. So best example is like if we are standing in front of a mirror, our image will be behind the mirror. And see, we cannot get this image on screen, right? The meaning of this sentence, okay? And last one, the image formed by a plane mirror is virtual if object is real if object is virtual, okay? So these are the points we have discussed till now. Let us now solve problems. Say first one, a man is walking with a velocity 5 meters per second normal to the plane mirror. Find the velocity of man's image. Okay. So here mirror is not moving, only person is moving. His velocity given normal to the plane mirror. See once how we are solving this one. Suppose this is now mirror, which is stationary. Now a person is walking towards a mirror. Given his velocity normal to mirror, that is a 5 meter per second. Now see the key point we are going to use. Distance of object from mirror is equal to distance of image from mirror. Okay. For example, if the person moves by distance sets, then image also has to move same distance sets. Relation is that distance of object and that of image from mirror must be same. If he moves by x, his image also has to move by x distance. That means we can say velocity of image will be equal to negative of velocity of object. So why negative means? Because when he is approaching the mirror, image also approaching mirror. That means their directions are opposite, but covering same distance in same time. That means having same speed. That means his velocity will be 5 meter per second. It is left side. Person is moving right side. That means when mirror is not moving, only object is moving normal to mirror. Then image velocity will be negative of velocity of the object. Okay, condition is object velocity is normal to the mirror. Now focus here one more point. One more important point. Suppose object moves parallel to mirror. Okay, either like this or like this. When object moves parallel to mirror, its distance from the mirror is not changing. Therefore, distance of image also does not change. Okay, if person moves, let us say y distance like this, then image also moves y distance. If object moves y distance like this, image moves y distance like this. That means if object moves parallel to mirror, then image velocity will be equal to object velocity. So you should be very careful. In first case, object is moving normal to mirror, then image velocity, negative of velocity of object. Next, if object moves parallel to mirror, then image velocity will be same as object velocity. So your condition is mirror is not moving. It is a stationary. Okay. Let us see next one. A person is standing in front of a mirror. If the plane mirror is moving with a velocity 3 meter per second, normal to its plane. Condition is normal to its plane. Then find image velocity. Okay. So person is not moving. Now see carefully how to start. Person not moving means object stationary. Now mirror moves. Maybe towards him or away from him. Okay. Let us take it moves away from the person. Right. So with some velocity v. Take it as Vm, velocity of mirror, which is normal to plane of the mirror, right? Now see what we can do. We are always saying that distance of object, okay? Distance of object is equal to distance of image. For example, initially distance equal to, so take it as d. Then distance of image also d, right? also D. Suppose mirror moves by distance x. Mirror moves by distance x. Then see distance of the object from the final position of mirror. This was the initial position. Okay, this was. Now it has moved by a distance x. This is now present position of the mirror. I am saying this is position 1. This is a final position. It has moved x distance. So distance of the object. It is now d plus x, right? How much? D plus x. If you see carefully, this is now initial position of the image. This is initial position of image. I am taking as I1. So from the position of the mirror, x, sorry, it is D, right? This is a D. Now it becomes how much? Since it is x, now this becomes D minus x, right? And you can see distance of object from the new position of mirror is D plus x. Therefore, image distance from the mirror must be D plus x. Now it is D minus x. So it has to change from D minus x to D plus x. That means image has to move at distance 2x. See carefully. If it moves distance 2x, then its distance becomes d minus x plus 2x, which is equal to d plus x, right? So distance of image from the mirror is equal to distance of object from the mirror. That means if mirror moves x distance, image has to move 2x, right? In the same direction. Therefore, velocity of image is equal to 2 times of velocity of mirror. Condition is this velocity is normal to plane of the mirror, right? Now see in the question given, velocity of mirror it is given as 3 meter per second. Then velocity of image will be 6 meter per second. Okay. Is a point clear? This is 3 meter per second means velocity of image how much? 6 meter per second.